As was mentioned before, today I want to talk about tracking progress in machine learning projects, why it can be a little bit different in comparison with uh, software development when we have no machine learning component, and why it's very important and why you as team lead should be in response for this part of development. And maybe many of advice from this presentation are relevant not only for machine learning area, but also for other areas as well. But still, I work in machine learning, so I will talk about machine learning. Let's start. And let's start from key topics for today's discussion. Today, I want to talk about what defines ML project and how it differs from other software projects, importance of using metrics for tracking progress in such kind of projects, about effective selection of metrics for projects, about best practicing in utilizing metrics for ML projects management and for effective management of your team, for how to motivate your team effectively with metrics. Okay, and at first I want to talk about what is ML project in general, because ML project can be really a very different thing. It can be something about self-driving. It can be something about financial values prediction, about generative AI like text-to-speech or chatbots. Some ML projects work under hood when you are looking for some videos in YouTube. It's about recommendation engine. You can make quality assurance on assembly lines with machine learning and much more things to do. Okay, but let's talk about what unites all ML projects. It's some non-determinant output. Always we have some ML program. Oh, sorry. Always we have some ML program inside, and it takes some input from outer world, from environment, and gives us some prediction. And what makes things hard, that predictions are not determinant, they are probabilistic. We can test our ML program on all possible inputs, and we can say which prediction we can obtain for certain cases. So it's not easy at all. And which challenges we have here? At first, as I mentioned before, such as output is probabilistic and depends on input data. It's not possible to test your solution on all possible inputs. It always be about some surprises in on production stage. So it's very essential here to choose a great metric to find as more problems as possible on testing stage, on development stage. Also, we want to achieve some high-level goals in our project. But usually it's challenging to formulate such high-level goals using numbers. It's not possible maybe at all, because numbers they can describe some certain conditions, certain inputs, but we can't create some universal metric to work with all possible conditions. And also, we need to understand what happens with our ML model on the low level. While high-level metrics can give us a good understanding of product quality. At the same time, we still need to understand why we have such result, why we have such quality. We need to explain fails of our model, of our project. And numerous factors can influence the final quality, because our model, our project depends a lot on training data, on labels of with data, on input on the production stage. So it can influence in a very different ways, and from time to time in very unexpected ways. Okay, let's consider a very simple example of machine learning maybe project. I don't know how to name it. When we have some image, we have trained neural network, and we want to classify dogs and cats. We want our network to predict is it a dog or a cat in this image. So even it's a really simple example, but we can think about some metric we can use for such approach, for such requirements. And maybe the first thing, the most easy thing I can think about, it's accuracy. It's accuracy of our results. For example, we can say, okay, our model has accuracy 37%. That means that it predicts the right animal in 38% of cases for 78% of images. But what if we have if you have more requirements for our product, like what if we can have cat and dog simultaneously in the same image? What if it's much more important for us don't fail predicting cat than a dog? And for example, what if our user have very non-equal distribution of cats and dogs, and like 95-5. For example, in such case, model which predict only dogs will have 95% of accuracy. Does it say that this model is great? Maybe no. Let's dive even deeper if we are talking about even more complex projects like text-to-image generation, chatbots, autonomous driving vehicles. It becomes even more harder how to define high-level metrics, how to define the metric of success there. The right answer that there is no single answer. There is no silver bullet, and every case is unique, maybe. But let's start why we need ML metrics at all. Why we just can avoid it. At first, of course, we need to specify success criteria for our project, because it's not possible to achieve something if you don't know how to measure it. If you understand how to measure quality of your product, you can create this product. If you have no ideas how to measure quality, you can create nothing. Also, to compare different models, especially it's very relevant in cases when multiple engineers work on the same problem in parallel. And for example, they trained different models, and we need to compare these models. We need to make a decision which model we should run into prod. Also, it's also very important for us to track potential quality regressions. As I mentioned before, very different aspects can influence on final quality of our model, of our solution, of our project. To diagnose problems with our model's quality, if we have a great set of metrics, even without checking output of our model, just by evaluating these metrics, we can say what is wrong with our solution, what is wrong with our model. And also maybe very important thing here is that metrics really can help you motivate your team, and it's so essential. It's so essential when you're a team lead to have some additional tools for team motivation. Monitor model in production. Okay, if it's possible, it's not always possible. And detect maybe some overfittings and underfittings of your model. It's when your model not generalized enough, or vice versa, generalized too much. Okay, and maybe let's consider more hard problem. But it's a kind of synthetic problem, but it's still realistic because a lot of real-life applications, a lot of products have such feature as AR mask try-on. I don't work on this solution exactly because it was taken from Snapchat, but I have a good understanding how it works under the hood. And it's also pretty important that here we have a good mix of high-level metrics and low-level metrics we can design to better track quality of our solution. At first, let's define some project success criteria. For example, we want 85% of users to be satisfied with our solution. We want our product to work in real time on a range of devices, and we want to ensure that our product is gender, ethnically, and age neutral. And maybe the second point is pretty easy to track. We have some device, we can launch our application there, we can measure frames per second on this device, and it's pretty easy. It's how to understand that we achieved this goal. But for the first one, a third one, it's not so obvious. So let's start from measuring high-level metrics. For example, for high-level metrics, we can, if we want 85% of people satisfied with our solution, we can just find some group of people and ask them what do they think about our solution. This approach has some pros and cons. Let's start from pros. At first, it really aligns with real goal we want to achieve. The metric is easily interpretable because we understand that 85% of people satisfied, so it means that 85% of people satisfied. It's nothing to interpret here. And we can also get some feedback from real users. We can get better understanding what do they like in our product, in our solution, and what they don't. And of course, this approach has a lot of cons. For example, evaluating this metric is pretty expensive because it's really hard to collect different people in, I don't know, maybe it's not necessary in one room, but still you should ask a lot of real people to rate your application, ask them about if they're satisfied with your application. Any test group of users, if we are talking about testing during development stage, will be not always representable because real users and test users always are different. It's, of course, we can try to find the closest distribution of test users, but still it's not possible. Also, it's challenging to evaluate this metric across age, ethnic, gender diverse groups because it just complicates the first one point a lot. Value of this metric says only about general quality of our product, but not about some certain low-level problems we have. For example, users are not satisfied, but why they are not satisfied? It's a good question. And percentage of satisfied people can't talk us about reasons of it. And every human-based metric is unstable and requires filtering. For example, we can use some crowdsourcing, crowd testing platforms for testing this approach for evaluation of this metric, but we need to filter results. Why people should answer to our questions honestly, and these results, they will be different from time to time because level of certifications depends not only on your product, it depends on users too. So it means that we need something more low level. For example, as I said before, I have a good understanding how this approach can work and what is on the hood of such solutions. Usually all engineers just predict some set of phase key points. And we can do very simple thing. If we have some test set of data, we can evaluate our model on this test set. And if this test set is labeled, we can calculate some distance between ground truth key points and predicted key points. Also, maybe we want to train some classifier for this solution because maybe there are such cases when person is not presented on the frame. So maybe we don't want to show flying in the air AR mask. Instead of this, we just want to say there is no person right now on the screen, so don't place a AR mask at all. And also, of course, if we have labeled videos, we can measure time consistency. If we have some age age, gender, diverse test set. We also can measure diversity consistency, how well our solution predicts points on different people. Okay, but of course, as high-level metrics, low-level metrics have their pros and cons as well. And pros here that they are easy to evaluate. We can evaluate them for no price at all. We can do it very often as we want to do. These metrics are interpretable. For example, if we have a low metric about key points prediction, we understand, oh, okay, maybe we need to do something with key points prediction quality algorithm, and we understand certain part of products which need to be improved. Okay, designing new metrics are straightforward. We can design 10 metrics per day if we need it. They can be directly optimized during the training. It's also a very important thing. We can use such metrics like loss functions during the training and optimize our goals directly, like key points quality, classifiers precision. They are easy to integrate into a CI/CD pipeline due to point one, as I mentioned. And of course, cons. Better metrics, better low-level metrics don't always equate to better quality. For example, you can improve your key points predictions metric twice, maybe, but still you can have no improvement at all at high-level metric level. There is an increased risk of overfitting due to such as we can evaluate these metrics really often, really easy, we can just overfit to this metric. We can train some model which can give us very good metrics values, but still it's not necessary about high-level quality. They often have a nonlinear correlation with high-level metric, as I mentioned before. So, what we can to do with it? And answer is pretty easy. We can combine all kinds of metric. We should to use low-level metrics. We should to use high-level metrics. Such as we can evaluate low-level metrics more easier. So it will be more about more frequent interactions with low-level metrics and more rare interactions with high-level metrics. Okay, but and high-level and low-level metrics have something similar. And at first, we can't blindly trust these metrics. Still, you need to investigate your data. You can't just check your metrics and, okay, my metric became better. That means all is great. No, from time to time, you should check your data. You should check model input, outputs. So there is no silver bullet. They should be revised from time to time, as I said, because some metrics can be outdated. You can ignore some metrics, for example, maybe some engineer decided, oh, it can be a really great metric, and he used it maybe once, twice, and after that nobody calculated it, and maybe it's not useful at all right now, and we need to revise it and delete. They can be a great motivator for a team, as I said before. And about motivation. Please show me by raising your hands who is familiar with such platform as Kaggle. Oh, one, two. Okay, okay. At least maybe 10 people. It's great enough. Let me talk a little bit more about this platform. It's platform about ML competitions. Different companies can bring their own datasets, their own metric, and users, ML engineers worldwide can participate in challenge. They need to get the biggest metric they can achieve. And it works like a great motivator. It's really about motivation because people maybe first 3 places first 7 places they really can get some money for participation, but usually in such competitions participate 600 700 people and they don't receive money at all for it. They do it just for fun. And why does it work? It works why they have metric. They have a way how to compare their skills with other people's skills, how to compare their solution with other people's solutions. And it's thing you can implement in your team too. If your team has a good understanding of goal you want to achieve, it can be a kind of competition. It can motivate people in a great way. Also, one more advice from me: investigate relevant papers for inspiration. There is a very small probability that your problem is unique, that nobody work on similar problems. Usually you always can find very similar research papers, really similar solutions, and it's a good place for inspiration. It's a good place to take metrics from, because at first you can compare your own results with other solutions, with other researchers. Of course, you can have different data sets, but it still can give you a great understanding about your abilities to achieve a greater result than you have now. Sorry, let me make a sip of the water. Okay. One more advice: calculate your metrics automatically. It's especially about low-level metrics because it's so easy to do it. And you can integrate it into your CI/CD pipeline. Because if your engineers have possibility, don't calculate metrics. In most of cases, they don't do it at all. Yeah, but if it's automatically, if it's easy to do, so it's much easier for you to track metrics progress. Okay, so calculate metrics. When you have a new model was trained, it can be implemented automatically. On new PR. If you, for example, if you use GitHub, you can, or any other version control system, you can make these metrics to be calculated automatically. It's easy to do. Just spend 1 day or even 1 week for this, but it can give you so much profit. And maybe from time to time you need to track your metrics just weekly, even without some triggers. It's also a good point for tracking quality regressions in your project, because you can, if you save results of such evaluations, you can revise it, you can understand what something goes wrong, with your project. Yeah, and of course revise metrics periodically. You can ask your really simple questions about every metric you have right now in your project. At first, ask, do I still take this metric into account when I make decisions about model quality? Does this metric still align with objective and goals of the projects? Because they can be changed, of course, with time. Is the metric sensitive enough to detect quality regressions or improvements of my model? For example, it's a very common situation if you designed a lot of metrics for your project. You designed a lot of metrics for a project, and two engineers in parallel trained two models. And some metrics are better for the first model, and some metrics are better for the second one. Green means better here, red worse. So, how to make a decision which model should be run into production? It's easy case when all metrics are green. Okay, we say this model is the best model, but in such cases it's not so obvious at all. So my advice here, how to deal with metrics hell. Try to understand reasons why some metrics are better and worse. Find the range of non-significant changes for every metric. For example, this model has better some metric value, but the difference is non-significant at all, and we shouldn't take it into our decision. Okay, and try to prioritize metric from less important to more important. It also can help a lot. And maybe the right answer here that there is no free lunch at all, and always even using this advice, it's still a hard solution every time. You still need to revise outputs of your model, why some metrics were improved, and still every time you need to make a pretty hard decision, and no easy way here. But this advice, they just can help to make this decision. Okay, and in conclusion, maybe we can talk about best practices for working with metrics. First one, don't rely only on metrics. Always examine your data, your model, your inputs. No metric is everlasting. Always find time to revise and review your metric. Delete outdated metric, try to design a new metric for new cases, new problems you have. Regularly update and change the data you calculate your metrics on, because for example you can collect some test set once and say okay, and I improve my metric already, I don't know, 2 years, but it doesn't work in such way, because test data for metrics calculation, metrics evaluation, they should be updated, and better do it as a regular practice. As a regular practice, for example, monthly, quarterly, I don't know, it can be different for different cases. Avoid seeking a one-size-fits-all solution, one-size-fits-all metric. It's not possible. It's not even for a simple example with cats and dogs. It's not trivial at all how to define model quality with only one number. Keep metrics straightforward. easy to understand for your team, for engineers, for business department, and add as much automatization as you can for metrics calculation, add it to your CI/CD pipeline. It should be really easy for engineers, even maybe for business people, to calculate, to launch calculation of some metrics on exact model, on exact data, to get some numbers about it. And that's all. Thank you for your attention. I'm ready to answer your questions.
Okay, thank you, Dmitry. And we've got a question already, too. 3. Who's giving more?
Thank you. From the point of view of manager, for example, you have an accuracy 50% and we need to reach 80%. Can you give me maybe not tools, but some advices how you can predict metrics for a business?
Okay, maybe the right answer here is that it's not possible. Maybe it's also another thing about ML projects. It's really hard to predict exact result you can achieve, exact quality you can achieve. You can only try to do it based on your experience, based on maybe some public available solutions, but if you have model, for example, which performs 50% and your business department says, oh, okay, we need to achieve 80%, 85%. You can, of course, give some kind of estimation for it, but it's not possible to predict how fast it can be achieved, if it can be achieved at all. So I'm always trying to give some distribution of my expectations. For example, there is pretty big probability that we can achieve 60% quality. Maybe in 2 months we can achieve 70%, but it's very hard to talk about very long-running results.
Thank you. The next question.
So thanks for presentation. I have a question. So sometimes business want to achieve some metrics that are very high, but could achieve in a reasonable time. How to say them that you can choose this metric?
Sorry, do you mean like we can achieve this metric, but not in reasonable time?
Yeah.
Okay, maybe if you understand that it can't be done in reasonable time, you also understand why it's not achievable in reasonable time. And usually, if you have answer for this question, I don't know, you understand why it's not possible. Maybe because, okay, maybe some cases need more data to be collected. Some cases need pretty long labeling process. Okay, and also in such cases, I'm trying to design some trade-offs. For example, okay, we can achieve such improvement very quickly, but I understand that we have bottleneck with our data quality, with our labeling process, and it's not possible to achieve higher quality without improving these processes.
Question number 3, please show your hand. Okay.
Thank you for your presentation. It was really interesting. My name is Anton. I'm a software engineer in G-Core. And my question is, you mostly were spoken about technical metrics. I mean, some model accuracy, maybe loss function, something measure this. That's really interesting. That's quite a new field, and I'm not an expert in it. But my question is, as a team lead, do you have some like a personal metric, for example, to say that in the end of the day you were good or bad, or how you were good or bad? Because like the only one that I heard it's about some technical stuff, model and so on. But for example, as far as I know, I might be wrong, but as far as I know, like the setup of the team is quite different. Like for example, from the developers team, typical developers team. So how do you measure the quality, your personal and your team? Is there some, like, I'm not saying about like some silver bullet, but maybe some methods, metrics, etc., etc. Thank you.
Okay, do you mean how to measure the performance of certain person?
Once again,
Do you mean you ask how to measure performance of certain person, certain engineer, maybe my own
Yeah.
performance? Okay, maybe it's all companies try to do using OKRs, and also it's why we still need people for to manage our people. If we have some metric to measure people performance, maybe we can just say, okay, optimize this metric, and this metric influence your salary directly, but it doesn't work in such way. It's a really big problem, because when I started my team lead role, then I usually have one-on-one with people. I should give them feedback about their performance, how well they perform, and also as engineer, I want to find some magic number to say, oh, you perform at all 72, and your colleague perform all 75. Please be better in the next quarter, but it's not possible. It's also about empathy. So.
Just to clarify, so you measure the quality of work, the performance, like say intuitively based on your previous experience. Yeah, got it.
Dmitry, is Anton on your team?
No, sorry.
There was a question, right? Or was that it? Okay. So here we've got a combo from two speakers, so watch out.
So thanks for your presentation. I got one question, which is related to the machine learning. I see that you are heavily working on the technical part. Fortunately, I had the chance to work in machine learning back to the time 2016. And I do remember we had 8 person just like working in data, and it was way too expensive to train a model. It takes days, months, weeks, and maybe a year. It's expensive by all means. So it's expensive by implementation, by time, by money. And I do remember we wanted to train one of the models that would take us like a year and a half to get it like 100% accuracy. I'm not working in the company anymore. That was so long. But we had a customer. He was from Panasonic, and we built an application for the police department in the USA. So they needed like 100% accuracy. And we had 2 options, whether to use one of the already pre-trained model, which was only available in Amazon, and that costed us like a 50K a month, which is way too much, or spend the time implemented by ourselves. So my question is, I see that from the metrics and your presentation, there was few cons that you talked about, that it is expensive. Now we're having all this hype, ChatGPT and whatever that is, it is. Is it worth it to use some of already the pre-trained model? Because it's, yeah, again, it's expensive, I know it, and yeah, perhaps echoing the question that whereas we need it by tomorrow, but we don't have enough time, and you just like you will hear You can go and use ChatGPT, and the customer has no clue what is going on.
Okay, yeah, it's a really great question because now open source can suggest you really wide range of really great performing models. And it's also a part of work of ML engineers to investigate public available models, to understand maybe their limits. Uh, if it's possible to use public available model, then it's great. You have a lot of time, you have a lot of money saved. Uh, just do it. Oh, of course, it also depends on the type of your company. If you have a consulting company, it's not so proficient for you to say, "Oh, we have something publicly available." But if you're a product company, okay, just do it.
So there was a case when ChatGPT went out, and there is one of the employee in Samsung that he used the ChatGPT integrated to Samsung, and there was a lot of data were exposed that was like way too popular on Twitter, and they talked about it. So is it this secure to use something that is open source and integrated to your own system?
At first, we should distinguish open source and self-hosted systems. ChatGPT is not self-hosted.
We don't always know what's under the hood in the open sources unless you go and dig.
No, I mean open source is like all code is available and you can launch it on your own servers,
Okay.
on your own site. So it should be pretty safe. But also, it's you should revise license agreement. So some companies care about it, some companies no.
Okay, I guess I should stop the shower of questions from Mahmoud. He's a killer. Okay, so thank you, Dmitry, for your presentation. And
Thank you.
there is our sweet present, okay?